Okay, so what we're going to do today is we're going to be looking at an important idea that's going to be with us through the rest of the semester. Okay, and um, and then two other ideas that also will be with us through the rest of the semester. Okay, so really, in this whole endeavor, this whole semester, we're really going to have only two equations. And I will show you what they are right now. Okay. The first equation is this one. Okay. We're going to say the sum of the forces is equal to zero. Okay. This is the equilibrium condition. Now, um, so that's a little summation sign. It looks weird because I'm on the iPad and all that, and they're hard to draw anyway. But we're adding things up. So what we're saying here is if we add up all of our force vectors for any situation, then they're going to add up and equal zero. Now, if they don't equal zero, then we get something completely different. We get this right here. And you might recognize that from high school physics, or if you took physics last year at some point. Okay. So if they don't add up to zero, then the forces add up to a change in acceleration or some acceleration, which is going to change your velocity. All right. Now, that is what we do in the spring. That's dynamics. Okay. This is statics. So all of our acceleration values are zero. So we're not going to have that relationship. Okay. The second relationship that we're going to have, equation that we'll be using, is that the sum of the moments is equal to zero. Okay. Now, we're going to talk more about moments later, but for now, you just need to know that a moment is kind of like a rotational equivalent of a force. A force tries to change something's position or its height or its shape, something like that. A moment tries to change something's rotation or twist it somehow like that. And for this whole semester, this is statics. So that's what we mean when we say statics. We mean that if we add up all the forces, if we add up all the moments, then they're going to add up to be zero. Okay. So let me set those aside for just a second because I'm going to need some space. Boop. Okay. A super important tool when it comes to analyzing forces and moments and that sort of thing is going to be what we call the free body diagram. Okay, the free body diagram. And if I've got some forces here, let's say I've got one here, let's call that A, and one here, we'll call that B, and then one here, we'll call that C. All right. What we can do with the free body diagram is we move those force vectors around. Because they're just a vector, it doesn't matter where they are. All right. All that matters is how long they are, their magnitude, and their direction. Okay. So the free body diagram is where we draw a coordinate system, X and Y axes on it. And then we take our force vectors and we're going to place them onto that coordinate system. Now, when you do that, the starting point of every vector always is at the origin. So we put vector A on here like this. There's A. We put vector B on here like this. There's B. And then vector C, we're going to put over here like this. And I forgot to put little hats on these guys. So let's get some hats on there. Okay, so that's what we call a free body diagram. Okay, it's a very useful, it's a very powerful tool to help us kind of analyze what's going on. All right. Now, when we have our free body diagram, it's also very useful to put the components on our free body diagram. So I'm drawing here the components of A. So I've got AX going upwards, and I've got, AY goes upwards. Sorry about that. And then AX is right along the axis there. Okay. Once we have those components, then we can work with them really easy. Because what we're going to do is we're going to take our main equation here and we're going to split it out into vertical and horizontal components. So what we'll be doing is we'll be saying, what's happening horizontally in my figure? So we want all of the X components in our free body diagram to equal 0. All right. And then we want to have all of our Y components also add up to 0. And that's how we end up using that thing. Now, the vectors I drew, A, B, and C, those are not in equilibrium. There's no way they're in equilibrium because I've got vector C that can oppose AX. So that could be all right. But vector B goes straight up and AY goes straight up, and there's nothing to oppose them. Okay. So we could look at those vectors, slap them on our free body diagram, and we can say, well, I don't know what this is, but I can tell you for sure it is not in equilibrium. Okay. Okay, so I'm going to stop this video here. Those are our main ideas. All right. The sum of the forces is 0. We want to take our forces and put them on a free body diagram. And once we have them on the free body diagram, we want to think about what's happening with the components of those forces, because that's how we're going to look at the horizontal and the vertical aspects of our situation. Okay.